Hey guys, it's Miss Farmer. So we are going to go over, or I'm going to teach this lesson that we are going to do today in class. So you're watching this. It is a lot of different standards because knowing the zeros of a function, which is 2.12, which is what we're doing today, is incorporated in a lot of different standards. So you'll see that here. All right, this is what our week looks like. We are on Wednesday, which is 2.12. This is the last part of Unit 2 that we're going to do because your test is on Friday. So I did suggest that today during class, after you watch the video, you take your polynomials practice test for multiple reasons. One, it's extra credit. Two, it could really help you prepare for your actual test. And then tomorrow when I go over it, I can't go over all of them. So what I'm going to do is I'm going to be taking requests for specific numbers. And then on Friday, you actually have your test. So you have nothing due physically today. If you didn't do your exit ticket 6, then you're going to do that during this time as well. Okay, so we are doing roots. So you will see two different things, roots of a function, zeros of a function. They're kind of the same exact thing. And the reason why it's called zero of a function is because you set it equal to 0. So do you see this trinomial right here? They have x squared minus x plus or minus 6. And we've done this before. F of x equals this, and then we graph it. And I'm going to be teaching you how to graph parabolas next unit. All they do is set it equal to 0, factor it out, and then set each factor equal to 0. So we have practiced how to get these two binomials before, how to factor it. All we're doing is this step right here. This adding, let me draw. I think I have my rainbow pen still going on. Let me change it. Can't go wrong with a rainbow pen though. So all we're doing is this part. This is the only thing you're adding on to your education today. Now, they're going to be called zeros of a function, roots of a function. They are where your parabola hits your x-axis. It's always going to hit it twice because a parabola is a u. So sometimes that might give you the graph, and it says, can you find the root of a function? And all you have to do is just recognize these two spots, which is 3 and negative 2, and it told you that here, 3 and negative 2. Pretty easy. So let's do an example. Okay, so let's do an example. So this is the normal thing that we've done. We're going to factor out this x squared plus 5x plus 36. So remember, we have to break down that 15. We're going to break it into two terms. And those terms need to multiply to be 36 and add to be 15. So numbers that can multiply to be 36, we can do 2 and 18. We can do 3 and 13. We can do, I'm sorry, that should be a 12. It's 3 and 12. My brain's working today. It can be 3 and 12. You can do 9 and 4. I've already kind of found my 2 though, because 3 and 12 add up to be 15, so I know that's the numbers I'm going to choose. So I have plus 3x plus 12x. Split it in half and take my GCF, which is x plus 3. And then the biggest number that goes into those two is actually 12. 12, and then we have x plus 3. So our two factors here are x plus 2 and x plus 3. We've done this. This is what we've been doing over the last couple days. The only difference, we are going to set them both equal to 0. So x plus 2 equals 0. X plus 3 equals 0. And then we just have to get x by itself. So minus 3 minus 3. X equals negative 3. Oh, I'm minusing 3 on the wrong one. Sorry, this is a bad recording. We have minus 2 minus 2. So x is negative 2. Over here, I'm subtracting 3. So when it asks you for your factors, these are factors right here. If it asks you for your roots, these are your roots. -3 and -2. So let's do 2 more examples. I'm going to factor this out. And then -12. So numbers that multiply to be -12 and add to be -1. I think that is -4 and 3. So I'm going to do -4 and +3. Okay, so I factored it out right. So now my 2 factors are x plus 3 and x minus 4. I'm going to set them both equal to 0 because I want my roots. And then I just, oh, sorry. I'm messing up all kinds of things today. I'm staying focused. I think I'm just going too fast is my issue. So -3, -3. And then I have +4. So these are my roots. And a lot of times how you know that it wants your roots is they'll put this entire equation equal to, they'll turn it from an expression to an equation and they'll equal it to 0. All right, so this other side is actually very similar. It just has +4 and -3 as their root, as the factors, so their roots would change. But I think we can move on. So in here it says solve, it doesn't say factor, and when it says solve and they have that trinomial equal to 0, what that means is it does want you to find the roots of the polynomial. So what you do is we have to factor this out again like we did before. So I have to find 2 numbers that multiply to be 9 and add to be -6. Well, I do know that -3 and -3 add to be, or multiply to be 9 and add to be -6. So I have x squared minus 3x minus 3x plus 9. So all I did was break down that -6 like we've been doing. Take out my GCF. Take out my GCF. Cool. So my 2 factors here are x minus 3 and also x minus 3. So it only really has one factor because they're the same. Because watch, it doesn't, once I set one of them equal to 0, add 3 to both sides, and my 0 is 3. But again, it's not going to say, using the 0 property rule, solve this. All you have to, but if it has it equal to a 0 right here, that's when you know that you need to factor this and then set your factors equal to 0 to find your zeros or your roots. And you can see your answers here are also not in binomials. They're looking for x equals something. So remember, it's not just because you get x negative 3, it does not mean your answer is -3. You have to set it equal to 0 first. Okay, so this was a super easy lesson. You have plenty of time in this hour to go take your practice polynomial quiz, and don't forget to write down questions after you take it that you want me to go over in class on Thursday. So I will see you tomorrow.